Hey, it's Paul Seaver. Another week, another video. So we're going to continue on, and right at the beginning, let me say this. Everything I'm going to discuss is in the context of water for human, plant, animal consumption. That's it. Change the context. Sometimes you change the meanings of the things that we're saying. So it's in this context for the whole, everything's about Esperer.H2O, which is a unit engineered for reconstructed water for human consumption. So that's what we're going to talk about. Okay. So now with that, we already covered a couple other subjects, like what's the difference between it and other ones and all that other stuff in the other videos. So as I was thinking this morning, it's still early, I gotta have my coffee. My coffee made with Esperer. That's a whole nother subject in itself. We'll talk about that when we get to beverages. So, what is Esperer.H2O? So, category-wise, it's acidulous. So, what I really wanted to talk about today is the term functional electrolyzed water. So, that's not a marketing term. It's a scientific term, and it means exactly what it sounds like. Water specifically engineered to perform a function. And so in electrochemistry, that's what you're doing. Now, typically we all know about applying pressure, adding or subtracting heat, using volume, all these different ways of using water. So then there's a whole nother way to use water that's manipulated by electricity. So, which is the same way Mother Nature manipulates it. So the category that we're talking about is acidulous. So acidulous is basically the neutral category. I said before, acidulous means the solubility of salt in water. That's all it means. All right, so we're in neutral. So basically the range of neutral, when we're talking about functional electrolyzed water, the range of neutral is approximately 5.5 to 10.5 pH. Now, this could get a little tricky as far as the pH goes, because actually in neutral there is no pH, and that has to do with the fact that in this specific neutral, it's a bonded dual ion, it's a bonded single ion from a basic and an acidic particle together. So once they're bonded together, they're neutral. That's it. They do not have a pH. And so really what we're measuring when we're measuring pH is the amount of power that we're putting on either the acidic side or the basic side of that solution. So it gets a little confusing in there. So we'll just leave that at that. Okay. Otherwise we're going to get too deep into it. That's not the idea. More coffee. I wrote myself a couple of notes to try to stay on track. It's difficult for me. So, acidulous. Acidulous is neutral. So, as we discussed before, you can have a pure acidic, you can have a pure basic, or you can have a neutral. So, a lot of people don't understand electrochemistry of water, but a lot of people understand statics. Okay, so, but statics is obviously different. And so the difference between statics and electrochemistry of water is in statics, you could build up a total charge in a piece of material and release it. We won't get into all the mathematics of how that happens, but everybody knows that. You can rub a balloon on your shirt, and you can go ahead and, or your feet on the carpet, or your head on something or other, and you can go and you can shock somebody. So you're building up an imbalance of static charge, and where that static charge comes from, if it's coming from the material you're wearing or whatever, you can release that static charge buildup. So, but in water you can't, because the charge that's applied, whether balanced or imbalanced, is stored in an ion as a single charge, which in comparison is very weak. You can't feel it. and it's insulated from all the other ions, so it can't store up a volume. Instead, it stores it and holds it because it can't release it. It has its point where it releases stuff, but that's a whole other subject. So in this context, it can't release it, it's storing it, it's holding it, and that's where the power is coming from. So that's the ionic product. So if you think about it in statics, so Mother Nature, when you think about imbalance of molecules, the difference between typical water, source water, single polarity nano, both of those are unbalanced. So Mother Nature's constantly trying to balance them. So that's kind of where this comes into play. So Mother Nature wants to make everything perfect. So in ambient temperature, perfect is seven acidic, 7 basic molecules, but it's constantly in reformation. So we're not going to get into that. But you'll never have perfect. You're always going to have an imbalance because nothing on Earth is perfect. So Mother Nature's constantly trying to perfect it. So even from the beginning of time, okay. So a lot of people hear about water has a memory, this, that, and the other thing. Okay, so water was the first molecule ever formed in the universe. So everything came after water, so everything has a moisture content. But Mother Nature set the rules in the beginning when it formed the first molecule of water. If it only had one molecule of water, it wouldn't be balanced, and everything has to be balanced. So automatically, if one molecule of water is formed, another molecule of water is formed. And so one will be basic and one will be acidic. It has to do with the transfer of the proton. Here again gets too far into what this is. But that's where balance comes from. It comes from the beginning. There never can be a single molecule, so you can never stay at an uneven number. It always wants to balance to an even number. Everything has to be balanced. So perfect balance is 7 basic, 7 acidic, pKw plus 7 minus 7. That's perfect. But here again, you're not going to find that. Now, probably already went too far with that. Yeah, that's enough of that. So what we do differently, just to put that back into perspective, okay? So Mother Nature's constantly using ionic product to balance. It's using the power of the acidics against the basics. There's your pH. It's going back and forth, back and forth, back and forth, trying to get it, but it can't get it perfect. It's constantly changing. So then we try to control it with single polarity, and we get it down to nanoclusters, but we never do achieve balance because you can't get perfect balance, and most certainly can't get perfect neutral. Then when we go to dual polarity, we can achieve perfect balance because we can manipulate both sides, and we put so much power on it that we now control it. We control where it goes and what it does because we have that much power, so that we can completely separate it so it can never join back together again, then we can rejoin it again, and so we can do all sorts of crazy ass things. So that's the power of dual polarity electrochemistry. So that's where the difference comes in. We control the balance. That's it. So, but when you go pure acidic or pure basic, at some point those are going to destabilize. Whether it's 10, 20 years, it doesn't matter. They will at some point. But the neutral should never. If it's never disturbed, it should never become unbalanced. All right, so we'll leave that alone. The power of water. All right. I know what I meant there. So most people understand the power of water through pressure, through volume, or through adding or subtracting heat, making boiling water or ice. So everybody understands the power of water through those things. But very few people understand the power of water through electrochemistry. Okay, so everything in the universe is run basically by electrochemistry, positive and negative influences. So in electrochemistry, all you're doing is you're going well beyond what Mother Nature does so that you can control those influences, and Mother Nature can't. Self-ionization, let me quit calling it Mother Nature. Self-ionization is what the actual term is. So water is self-ionizing, okay? So in order to interrupt self-ionization, you have to overpower self-ionization. So we do that by 10,000 times. So that's why we have the power to do what we can do. All right, so once you can do that, so you can use the water for more things. So when you decide where you want it at, in this case we're going into neutral. Now we can get it down to, as we discussed before, to single molecule, single ion rather than a cluster. So where's the difference in that? Human consumption has to do with making it available for uptake through aquaporins into your intercellular fluids. Now, I'm not going to get into human health sciences here, but this is no different in any organics. It doesn't matter if it's a bacteria, it doesn't matter what it is, what kind of cellular thing it is. If you want to get past the membrane, you gotta go through an aquaporin, period. Okay, so all of this has to do with being able to deliver a payload into the intercellular fluids where it belongs, whether it's a pharmaceutical, a nutrient, a pesticide, hydration alone. So with the power of water, you can't use heat to do that for the human body. You can't use pressure to do it for the human body. You can't use volume to do it to the human body. You gotta absorb one molecule at a time. So how do you do that if you're just drinking a bottle of clustered slush on a molecular level? It's impossible. That's why most people are dehydrated. So you gotta break those molecules up. How do you do that? Ionic product. We already discussed what ionic product is and how do you achieve ionic product. So once you break all those molecules up and they're highly charged and everything's balanced on top of it, because we're talking about a balanced neutral. We're not talking about an acidic, we're not talking about a basic, we're talking about what your aquaporin's looking for. Not qualified to get too deep into that subject. The only thing that I know is aquaporins are selective. They will only uptake what they're looking for. That's why people are dehydrated all the time. You know, because you don't have what they're looking for. You have to have something that's balanced, something that's pure, something that's clean, something that's there for hydration. Not coffee. You ruin the Esperer when you make the coffee, but the Esperer sure makes the coffee taste good. So anyway, the power of electrochemistry gives you that power to break up those water molecules into single molecules balanced by dual polarity electrochemistry using only, balanced salts, sodium chloride. So, in the power drinks and stuff, they just call it adding electrolytes. So instead of adding electrolytes here, TDS, or, you're talking about TDS. Oh, the subject just goes so far. It's hard to not stray off on different things. We have to talk about TDS at a different time, but man, these commercials on TV are just BS. You don't drink zero water. Zero water is useless. There's very few uses for zero water. You have to have content in water, and if you're a human that's living on planet Earth, you need TDS in your water, period. And that's as far as I'm going to go with it. Now, for electrochemistry, you also have to have TDS in the water. There's nothing to electrolyze. And so you have to have a minimum amount of TDS. Big surprise, it's the same minimum you need for human consumption. Geez, I wonder why. Because we're running off the rules of Mother Nature and what Mother Nature considers balanced. So in the Esperer systems, the way I make them with my RO system, I try to get the TDS down to about 50 parts per million. That's the minimal needed for electrolyzing. Now you can get more hydrogen content and stuff like that if you raise the TDS level, but it's just numbers. Don't get caught up in numbers. If you got dissolved hydrogen in your water as you're consuming it, you have an infinite, if you can measure it, you have an infinite amount of it. Don't get caught up in numbers. We're not going to get too deep off into that because that has more to do with gases. So the power of water. So, like I said, you're breaking up the clusters and you're making everything available for uptake through the aquaporins into your intercellular fluids. So why is that important? So that's important for flushing your system. So, in my specialty, it doesn't have anything to do with human health sciences. It more has to do with hydrothermal operations. But the human body is nothing more. Oh man, I'm already on 15 minutes. I'm on subject 3. the human body is nothing more than an organic hydrothermal system. It's a little bit more complicated, well, a lot more complicated, but basically it don't run any different than a cooling tower for a air conditioning system. All it's doing is exchanging heat. But in order to exchange that heat properly and efficiently, as well as keep the system clean of all the things we pollute it with, you have to absorb water into your intercellular fluids and then move it outward. That's why one of the best things that you could do is drink a glass of water before you go to bed at night. No, it won't make you wake up in the middle of the night and have to go to the bathroom. What it does is it offsets the amount of water you evaporate through breathing while you're sleeping. And so therefore, if you don't wake up in the middle of the night dehydrated, thinking, most people don't understand. You're waking up in the middle of the night because you're dehydrated and you need a drink, not because you have to go to the bathroom. You have to go to the bathroom because you woke up in the middle of the night. You get to change your mindset on that and the whole thing will change. And then the next most important thing you could do is drink a glass of water in the morning to start your circulating system moving again. But you gotta have the right water. If you're not absorbing it, what difference does it make? You can't drink a gallon. You gotta drink something that you can absorb. So that's where electrolyzed water comes in. I'm gonna try to fly through some of this stuff a little faster. So I'm gonna stay off of the gases, but yeah, I'm just gonna stay off the gases. Okay. Highly charged ions. We already talked about highly charged ions. What does it do? It makes all the water molecules available for uptake. And that is your delivery system. That's your delivery system for your nutrients, your pharmaceuticals, your hydration, and to flush your system, which we already talked about, so I can roll through that too. So, why do we... I'm gonna end this on one thing. Not that it's the end of the subject, just to keep the video from being way too long, which it already is. Hydrogen. You hear a lot about hydrogen. Hydrogen for this, hydrogen for that, hydrogen for everything. Well, that's because it's the strongest electron donor in the universe, so it's the best thing to balance all reactive oxygen. And what are we doing? We're constantly flooding our environment with reactive oxygen. So how can we balance it? Hydrogen. So it has to do with our own systems too. We get our own reactive oxygen through sodium chloride, but your body knows how to use that, and it's using that for its own defenses and things. The problem is when we come into these environmental hazards that give us even more. And so with these units, okay, so when you get like there's lots of different systems for doing hydrogen. You can do hydrogen sticks, you can, God help you do hydrogen gas. You can do single polarity, all these other things. The problem with these other things is they're not balanced. The only thing you're doing is getting the hydrogen. That's it. But how do you so now you're leaving it up to your body to have to balance that out as you're taking it in. So it's no good. So when you have a balanced unit, you're getting balanced hydrogen, reactive oxygen. The interaction between the two is oxygen. And so you're getting it at the proper pH, which is 7.4. Okay, so the gases at the pH that you get them is very important. People don't understand in most cases the things that they're thinking about that are being done with the solutions that they're using is done with gases, but you don't see them. Sometimes you smell them, you smell the vapors of these gases bleeding off, like when you're using bleach or hyperchlorite or even hyperchloric acid, you're breathing these gases that are coming off. Depending on what it is, there's your sodium hydroxide lye, hydrochloric acid, think of all these things that you can smell, and that's what you're smelling the gases. So in electrochemistry though, none of the gases are toxic. You can make different gases in a strong enough concentration where you can smell them, like chlorine, and I can make it in a range all the way from dissolved down at low pH to stored at high pH to released in the middle. So that's what we're doing. We're manipulating the gases, but we're doing them in a balanced way, depending on what we want to do with it. So this unit is designed to balance the hydrogen with reactive oxygen and oxygen so that you take in a perfect fuel. Your body doesn't have to process nothing. It can just use it. It doesn't have to counter anything you're bringing in, because what you're bringing in is already balanced. So it doesn't have to offset it. Okay? That should be easy enough to understand. You know? And then same thing with the pH. So since it has no pH, but the power is brought up, it's complicated. Electrochemistry runs under different rules, okay? So it's hard to cross the rules over. So if you use a standard pH meter, really all you're measuring is the amount of power that you put on that particular side. So we make sure that there's enough balance to balance everything up to gases and things to where they're at equal to 7.4 pH, so that they're 100% usable, absorbable, and compatible to the human body. So you don't get that from single polarity. You get 10 plus pH with a high rate of hydrogen. Don't get caught up in those numbers. That doesn't mean it's better for you. Okay, it's not like octane gasoline for your engine. You're not going to get more horsepower from it. What you're going to do is you're going to cause a cascade of other things to happen in order to counter the fact that you flooded your body with too much hydrogen. Ion balance, that's what we were just talking about, pH. So you're getting a balanced ion. Your body doesn't have to balance it. The electrochemistry already took that sodium chloride that's essential to life. You will die without sodium chloride. So as a solution, single salt, sodium chloride, balanced to 7.4 pH, your body can automatically use it. It doesn't have to process the salt. Okay, and so the last thing I wrote down there was human balance. So that's the whole idea behind the unit in the first place, is what is perfect human balance for hydration. And so it involves a lot of subjects. It doesn't involve just one thing. There's no marketing story to go along with it. It was just the original development of it had to do with the prevention, treatment, and cure of cancer through hydration, nutrient, and pharmaceutical delivery. So that's what the idea was in the beginning. You know, how can you help people who are sick? And most of the time, most people know if you're suffering from a serious illness, you're always suffering from dehydration, which is one of the reasons that your pharmaceuticals and nutrients and stuff isn't working. So once you can get your system back to a hydrated level where it can start processing all these things, then all of a sudden you get much better. Doesn't mean it's a cure for anything. It just means it helps everything work better. And it doesn't matter what the subject is, as long as it has to do with water. You know, so we'll get into some of that other stuff, hydrothermals and beverages, all sorts of different things. But for the human, right now we're only talking about Esperer and Esperer for the human body, and to try to keep it simple and try to keep the videos short, which is almost impossible. So I'm going to end this one here for now, and the next time we'll just talk about something different. Adios.